Okay, boys and girls, last lesson we stopped at lesson number 47. We are doing the past year questions. Past year questions, which is 2018 to 2022 lah. We will select some of the question to answer. Okay, so this is what we are going to do. And then next week we will continue the next chapter lah, which is our last chapter. After that, we will keep on doing some selected past year question. Okay, so here. Define the electric potential difference. Okay, we understand that potential difference. Actually, a lot of definitions we can using formula to explain it, but not all. Not all. Okay, for example, this one, potential difference is actually the work done, or we say energy, okay, per unit of charge, right? Okay, this is the formula for potential difference. So at here, when we will say that work done, or we can say energy transfer, in driving one column of charge from one component, from one point to another component, from one point to another point. Okay, so at here we write down energy transfer, okay, in driving one column of charge from one point to another point, or we say across a component point to another point. Okay, sometimes they will asking you define the potential difference in terms of energy. So how the energy transfer in potential difference? It is transfer from, here I write down, electrical energy to others form of energy. Okay, others form of energy. Okay, so if let's say this is a heater, then it will transfer to the thermal energy. Or maybe this is a resistor. After current flowing through the resistor, then at the end, thermal is produced. So it depends on what is the output lah. Okay, so this is potential difference. If today the question asking you what define the EMF, actually formula is the same. Okay, but here normally EMF we give the symbol of E lah, okay, capital letter E. So how we are going to define this EMF? We will say that energy transfer in driving one column of charge around a complete circuit. So can you see that the front part is the same, just the behind part is different. Okay, if the question asking you in terms of energy transfer, define about the EMF in terms of energy transfer. So EMF is actually for the power source. Okay, let's say it's battery. So we will from chemical energy to electrical energy. Okay, chemical energy to electrical energy. Chemical is because of the battery. Then electrical is because the current flowing through the circuit. Then can you see that EMF we producing from chemical to electrical. Then for potential difference for this component, for the external component, they will from electrical energy to others form. Okay, so next be at here. A cell of electromotive force 1.8 volt and internal resistance R is connected in parallel with a resistor of resistance 6.0 ohm and a filament lamp. Okay, the switch S initially is open and meter reading is 0.25 ampere. Can you calculate the internal resistance? If you didn't refer to the previous note, do you able to answer this question? Can you try it right now? At the same time, I take attendance. Okay, you try and then you type your answer in the chat box. Okay. So any of you get the answer? Oh, Chong Han so fast. Okay, 1.2 ohm. Yes, very good. Jore, yes, correct. Washini, yes. Okay, dear. So when they are open circuit, you don't need to consider just using E equals to V plus IR. I told you, once you saw internal resistance, this is the formula. Okay, this will be the formula. Of course, sometimes this one we put I times R lah. Okay, so at here, this one is 1.8 equals to dV. V is, okay, we can put I lah. I R plus R. Okay, so 1.8. The I is 0.25. Okay, so at here 0.25. This is 6 plus unknown R. So if you do it correctly, everything correct, this one will be 1.2 ohm. Okay, so next question C. Okay, for others who didn't type your answer in the chat box, do you able to get this answer? Is it okay? Can we proceed to the question number C? Give me response so I know. Okay, Fawa, Kai Chen, oh, okay, Wesley, okay. Like dear, the main thing I want to mention is here, okay? So at here, look at this. At the time T1 switch S. Okay, so at time this T1, close the switch, close the switch. So figure 7.2 show the variations with time T of the M reading. Oh, okay. So at time T1, we close this cell. Okay, we close this cell. Then the question, the graph is showing you the current, how the current change. Okay, this is the current change. Suddenly it increase and then decrease. Okay, so step whether the EMF of the cell after T1 is greater than, less than, or the same as it was before T1. What do you think? What do you think? When I close the switch, what happened to the EMF? Increase, decrease, or the same? Okay, greater than, less than, or the same. What do you think? Fatima, no. Fawal, no. Wesley, yes. Wesley, yes. Chonghan, yes. Vashini, yes. Dear, EMF is way. EMF is this part. Okay? EMF is this part. Okay? So when we close the switch, we doesn't change about this one, what? Right, dear? You didn't change about this part. Okay? So the EMF should be the same. So at here, we write down the same. Okay, the same. Okay, then here, by considering the effect of the lamp on the total resistance of the circuit, explain the variations of the ammeter reading. Actually, they want you to explain. After we close the switch, we are including the lamp in our circuit. Okay, so when we including the lamp in our circuit, we found out that the circuit suddenly current high. Then after that, here it decreased. So actually, they want you to explain why current change in this way. Okay, so we need to explain 3 mark, 3 mark at here. You need to explain before, then after that why suddenly increase, then why decrease. Okay, this question needs you to think. So can you think and then you type your idea in the chat box. Try to think why. Before that, before T1 is before we close the switch. Okay, so the current is constant. So you explain why. Then after we close the switch, why the current suddenly increase? Then after that, we keep on letting the circuit flowing, but why the current starting to decrease? Think. Fawal not really answer the question. Current. Current related with what? Fawal, try. Or before T1. Okay, any of you trying to type. Before T1, which is here, why current constant? Why current doesn't change? We step by step, you type your answer and tell me why before T1, before T1. Okay, what happened to your current? Current is constant. Can you explain why current is constant? Current always related with what? What affecting the current, dear? Wesley, yes, you score 2 mark, Wesley. Let me have a look, Vashini. Yes, Vashini answer very good. Okay, let me have a look. Fatima also correct. Okay, I read the Vashini answer. Before T1, current is constant. Total resistance is constant. We have nothing changed to the resistance. So boys and girls, you look at, okay, before we close the switch, the circuit is this. Okay, this is a fixed circuit internal resistance. This is a fixed 6.0 ohm. No matter how long the time we let the current flowing through the circuit, your resistance doesn't change. Your EMF doesn't change. So just now, who was the one answer? Fawaz, is it? Fawaz said EMF and internal resistance stay the same, but you didn't talk about this. If you say that EMF, internal resistance, and the fixed resistor is the same, so current is the same before T1, then correct. Okay, you ignored about this already. So boys and girls, current is affecting by resistance, of course EMF also lah. Okay, so just now at here we already mentioning EMF is the same. No matter close the switch or doesn't close the switch, it will be the same. So current will be affecting by these two. Since before we close the switch, this two is a fixed resistor. So nothing changed for the current. Each all the time will be constant. Okay, when we close the switch, why is suddenly increase current? Okay, now you give me the answer. Why suddenly current increase? Just now, Wesley, you score 2 marks is because there is a 3 point here, 3 mark here. So you have to explain before T1. So your explanation is after T1, but your okay, so you lose 1 mark. Kai Chen correct. Kai Chen correct. Okay, at T1, any others want to try? Manjo? Why at T1 current will increase? When we at the moment we close the switch, then current suddenly become high. So you always think about current and resistance. Okay. So Vashini said that at T1 current increase as total resistance decrease. Correct. Okay, I write down first, then I come back to the circuit. Total resistance decrease because let me draw out the circuit. Okay, because when we close the switch, here, like this, I need to include this, the lamp part. Then here, I got internal resistance, so I got the battery here. So boys and girls, can you see that? The external circuit at here, the resistance actually in parallel. Resistance in parallel, they will cause this part of resistance decrease. Okay, the properties that we connect the resistance resistor in parallel way is we will decrease the resistance. So at here, if you're including the internal resistance, so in total, our total resistance will decrease, so the current will increase. So once we close the switch, it suddenly increase the current is because our total resistance decreases. Okay, now this is the second point. Third point, we have to mention after T1, why it suddenly decrease. Okay, let you think 10 seconds trying to think why. Okay, after T1, current in the ammeter decrease. Okay, why? Try to think and then try to give me some idea. Wesley, very good, huh? You know the idea. The resistance. Current decrease must be the resistance increase. But why? Why it increase? When I close the switch, let the current keep on flowing. Then after that, current decrease. So you think about resistance. Current decrease, of course, resistance must be increased already. But why why resistance increase? Okay, Kai Qian. Kai Qian correct. Yes. Washini, after T1, temperature of the lamp will increase. Very good. Temperature of the lamp increase. Hence, the resistance of the lamp will increase. Total resistance increase. So current in the ammeter decrease. Very good. Perfect, your answer. You got the answer, is it? Perfect, very perfect. Okay, current in the ammeter will decrease because, okay, temperature of the lamp increase. So, resistance of the lamp increase. Okay? Here, 3 mark is before, after, before, at, before T1, at T1, and after T1. Okay. 10 seconds for you to complete. If you complete, then you give me reaction, then I know that we can proceed to the patch 10. Fatima, okay. Chonghan, okay. Wesley, okay. Fawa, okay. Very good. Kai Chen, okay. Then, dear, let's go. Question number 11. A battery of EMF 9.0 volt and negligible internal resistance is connected in series with a variable resistor X and thermistor Y. So this one is the 5.2 is show the relationship between temperature and resistance of the thermistor. Okay, so that means that we must be from here can find either from resistance to temperature or they given us the temperature to find resistance. Okay, here the current in the circuit is 1.1 times 10 power negative 2. Normally, I will using pencil and label in the diagram. Okay, when I answer, I refer back. I know that what information I have 1.1 times 10, 1.1 times 10 power of negative 2 ampere. Using pencil, if let's say we label wrongly or we calculate wrongly and we label in the diagram, at least we can erase it. Okay, next, potential difference across Y is 4.0. So I will come back here. This one is 4.0 volt, total 9.0 volt. So normally I will be here 5.0 volt. I will write down whatever I know on the diagram. Okay. So next, can you get the resistance X? Can you calculate the resistance X? So trying to have the habit, label information that you know. Then now the question asking you, what is your Rx? Do you ever to find it? Chonghan, no. Resistance, my dear. Not asking you voltage. Yes, correct. Correct. Any others? Do you able to get the answer? Should be easy, right, dear? From the diagram, if you label the things that you know, actually very fast you know what you want. Washini, yes. Sean, do you round it? I means like just now got 2 students, they give me 3 significant figure, but the last significant figure is different with you. Okay, Wesley, yes, Wesley, correct. Yes, now Sean, correct. Okay, dear, can you see that when we label everything, we know that V equals to IR. This one is V for X, R for X. This is a series circuit, so current doesn't matter. It will be the same 1.1 times 10 power of negative 2. So Rx. So your V is 5.0 lah, okay? So your Rx If two significant figure is 540 ohm. If three significant figure just now your friends giving me, it should be 455 ohm. Okay, so this one easy. So dear, next. The temperature of Y changed to 190 degrees Celsius. Resistance X remains unchanged. Just now we did calculation at here, 450 ohm. So that means that your resistance X still 450 ohm. Can you calculate the new potential difference across Y? Vy right now. Just now is forward. Right now already changed. Why change? Because temperature change. Resistance will change. So dear, can you try? 190 degrees Celsius. So must be related with the graph provided to find the information that you want. Can you try? Okay, let me check Fawal answer. Fawal, no, Fawal. What is your Vy? Voltage for Y here. So I label it here 450 ohm for me, Vx. So do you know your Ry? When 190 degrees Celsius, what is your Ry? Then from here, do you ever to calculate the voltage Y? Chonghan also no. Wesley no. Is it my problem, dear? No. Vashini halfway. Yes, Ry is this. Then do you able to? Yes, Vashini correct. Then how about others? I guide you guys, dear. Look at me. Now the question say this one is 190 degrees Celsius. Okay? So what is the voltage Y? V1. So this one, I know is 450 ohm. I don't know this resistance. But if I know, I can using potential divider formula to do calculation. Okay, what information we can get from this 190 degrees Celsius, dear? This is for thermistor. You see the graph is for thermistor. So at here, 190. So draw from here. The graph must be some information we can get from this. Okay, so at here. So this one is 25 ohm. 25 ohm. So at here, this is 25 ohm. Until here, do you have idea how to find the voltage Y? Do you have? Let me like this. Okay, clean this. Do you know what is the voltage across 25 ohm? You don't try using this current, just now the current, because now your resistance is changing, so your current will be changed also. The red color current is only for previous question. Now you having a new resistance, you cannot using this current times the R, cannot dear. So potential divider formula, can you? Chonghan correct. Fawal, yes, correct. Fatima, no. Okay, dear, at here, I erase this part, okay? Because this is just now the circuit, okay? Now we change the resistance, current will be changed. I cannot use the previous current. So this one, can you see that this one? 25 divided by 25 plus 450 times total total voltage 9. So your answer at here should be 0.47 volt. Is that clear? The doesn't matter. You can using mathematic ratio. Total resistance is how many? Total resistance will be pairing with total voltage. Okay. So at here, total resistance is 25 plus 450. So it will be 9 volt. 9.0 volt. Okay, so ask yourself 25 ohm. 25 ohm, how many volt you will get? Using mathematics lah, dear. Okay, so I can using like 25 over 25 plus 450 equals to the unknown voltage Y divided by 9. Okay, so this one is unknown Y. Okay, I move this to here. 25, what is the voltage I get? I don't know. Then total resistance is 25 plus 450. I will check the 9 volt. So from here, you do the ratio. Okay, you not ratio, you do your mathematic way. Okay, then after that, from here, actually, you move the 9 to another side. Actually, Vy will be equal to 25 over 25 plus 450 times 9. So dear, can you see that it's exactly the same thing? If let's say you really forget about the formula of potential divider, doesn't matter. Using mathematic ratio method, okay? Answer should be 0.47 volt. Is that clear? Can we proceed to the next question? Fatima, okay, Okay, dear here. Okay, the question said that resistance X is increased. Resistance X is variable, okay? So at here, maybe I can draw like this, like this, like this. Okay, variable resistor. Then after that, like this, like this, like this, like this, like this. Okay, the Rx will increase. Okay, Rx increase, temperature remain, Ry remain at 190 degrees Celsius. So by reference to the current in the circuit, so you need to mention what happened to the current. State and explain the effect of this. Effect of this is Rx increase. Okay, if any on the potential difference of Y across Y. So what happened to your Vy? When you are increasing, number one here, increasing the Rx, what happened to your Vy? So think. 3 marks, Fawal, very good. Yes, correct. Fawal, 3 marks, yes. Chong Han, you want to tell me you are going to score 3 marks? Vashini, yes, 3 marks here. Okay. Chong Han, try how you're going to score the 3 marks. Wesley, Prasan. One more student, try. Jore, yes, Jore. Uh, Jore answer in this way, you can score 1 mark. 1 mark. Chonghan, yes, but what happened to your potential difference across Y? You score 2 mark already, then what happened to your potential difference across Y? Okay, so they're asking you potential difference across Y. So our answer should be potential difference across Y decreases. State and explain. So I will explain why. Okay, because your total resistance will increase. Total resistance increase. Okay, so when your total resistance increase, your total current will decrease. Okay, so total current decrease. Okay, so Vy is actually I times the R, right? Ry. So since the Ry doesn't change, because it's still maintained at 190 degrees Celsius. So Ry is maintained. Your current already decreased. This current decreased. So the voltage across Vy also decreased. Okay, that's why voltage across Vy decreased. So number 2, number 3. Okay. So this is how we score these 3 marks. Is that clear? If done, then we go to the next question. Fatima, okay? Fawa, okay? Any others? Okay, so we go to the next question, page number 12. Okay, dear here. Without referring to the previous note, I teach you the technique. We don't need to memorize how we derive. I did teaching you. So at here, I want you to think. Okay, how we get this formula by using Kirchhoff law. Okay, so at here, look at the parallel. I teach you that you think what physical quantity is equal what. So from there, you continue derive it. Okay, so boys and girls, so you look at this. This one is voltage is the same for parallel. So I cannot say voltage 3. Then how can I derive the plus plus plus? In the equation, they got plus plus what? Okay, so I cannot using V as my starting of derivation. So what will be plus in the parallel circuit, which is the current. So we start from current. So I is equals to I1 plus I2 plus I3. Okay. Then how we relate the I and R? We understand V equals to IR. So your I is actually V over R. So at here, every single I, we put V over R equals to V over R plus V over R plus V over R. Then I label R1, R2, R3. Then this is total R. Okay, dear, here. Then how we going to become 1 over R? Where is the V going? Why the V suddenly disappear? As we told you in parallel. Okay, voltage is the same. So that means that voltage for VR1 equals to voltage for R2, voltage for R3. Okay, they will be the same. So actually this one can be cancelled out. If you factorize it out, then you can cancel it out. So we will get 1 over R equals to 1 over R1 plus 1 over R2 plus 1 over R3. So dear, this derivation, no need to memorize, but you using the technique to know how to derive it. Okay. So we start from the current because in parallel circuit, we are adding up the current. Okay. One more. This one is actually using Kirchhoff's law. Okay, Kirchhoff's law. Kirchhoff's law. Okay. Conservations of charge. Conservation of charge. Okay, this one should be no problems. Just recall only. So at here B. Okay. I'm not sure. I'm feeling like this question is so familiar. I'm not sure. Maybe we did it before. Okay, a battery of EMF 8.0 volt and internal resistance R is connected to 3 resistor. Okay, so next question said that resistor Y, this one Y, have a 16 ohm. Okay, already labeled. Current in X is 0.49 ampere. The current in Y is 0.45. What is the current in the battery? Is it? What is the current in battery? Once you saw in battery, that is meanings of total. Okay? Because starting from battery out and go back to battery. So can you please tell me what is the current in the battery? Vashini correct. Fawa correct. So they're based on the diagram, very easy, right? Total current is actually 0.49 plus 0.45. Kirchhoff's law. Okay? So at here, Wesley, yes, correct. You need capital letter A, capital letter A. Okay. So this one easy, right? Okay. So what is the internal resistance R of the battery? Okay, can you guys try? What is your internal resistance? I told you already, once you saw internal resistance, actually there is only one formula. So try. Chonghan, yes. Oh, I write wrongly. Oh, thank you. 0.94, dear. 94. Thank you, Chonghan. Okay, dear, can you guys try? What is the internal resistance? They will only have one formula. Okay, so try to find your small r. Vashini, yes, correct. 8.0 is confirmed. What is your V? Then what is your I? Then what is your R? Do you know where to find your V? Do you know what is your I? I got 3 I at here. 0.49, 0.45, and then the total is 0.94. Which I I'm going to use? Chonghan, correct. Fatima, correct. Oh, very good idea. Okay, dear, at here, I want to emphasize for this question is, these two is parallel path. The voltage, it should be the same. Okay? Wesley, correct. Fawa, correct. Okay, so for this part, I cannot count the voltage. It's because I don't know the resistance value. So what should I do? I'm using this part as my V, external circuit V. Because these two are parallel, they will be the same. So at here, I can using 0.45 times 16 plus I. What is the I at here? Dear, this is internal resistance here. So you have to using the current flowing here. This one, I. This is your I. So what is your I here? This is total current. So it's just now the 0.94. Sometimes, why they ask you to calculate this? Maybe they are helping you for answer next question. So this value, okay? So at the end, if you do everything correct, your answer should be 0.85 ohm, okay? Remember, I want to emphasize this I actually is the current, total current. Okay, total current. So this V is any path as long as they're parallel, their voltage should be the same. Okay, next, boys and girls, can I proceed to the page number 13, question C? The rest of you able to follow? Okay, now let's go. So at here, do you memorize the formula? Can you calculate resistor X and Y are made from same wire of same material? Okay, you have to know when same material, what will be the same. Same one, same. So this same. Okay, the drift speed is, so this one is Vx. The question asking you Vy. Okay, so this one, formula for this current is ANVQ. So at here, can you try to find what is your Vy? So if I rearrange, V is I divided by ANQ. So at here, same material, VIANQ. What is the things, what is the physical quantity? It should be the same if they are same material. Okay, so at here, hints are same material. Washini, correct, very good, thank you. Dear, N should be the same. Same material, same M. Okay, so can you find it out? What is your Vy? Try. Chonghan. Yes, very good. Chonghan, very good. Jore, yes. Jore, very good. Correct, correct. Any others? More and more? Make sure you guys know. Vy over Vx. I always like to using ratio, because some of the variable, we can just cancel out. We don't need to press a calculator. Washini, correct. Dear, every time they give you, hey, for this material or for this is this. characteristic or properties. Then after that, find another one. I like to using ratio like this because they ask. I will over the speed for the x. So at here, I over a and q. Then I must be very understand. This one is iy, ay, ny, and q. Then divide. Actually, divide. If I change to times, your mathematic, we need to flip it. So this one should be a and q over I. But this part is x. So ax and x. Okay, here just now we got mentioned area is the same. So I cancel. Same material, n is the same. Q is the charge. Charge. 1.6 times 10 power negative 19. Of course, if you want to put the value in, you'll also get the answer. But if possible, I will just cancel out. No need to press so many digits in the calculator. Maybe we'll press wrongly lah. Okay. So for the Q at here, we also need to cancel. Okay, like this. Wesley, correct. So there, from here, I know that Iy over Ix is the ratio. Okay, so at here, I should be Iy. What is my Iy? Wait, da, 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 da. My Iy, come back to here, Iy. Oh, Iy is here, 0.45. Ix is here, 0.49. Okay, so at here, come back, 0.45 over 0.49. Okay, then at here, this one is Vy over Vx, right? I move the Vx to be here times Vx. So I should be times what? Vx voltage across x. Let me have a look. Vx at here is, oh, here, they tell you, wait. Oh, Vx is here, there, this one. Okay, 2.1, 2.1 times 10 power negative 4. Okay, so your answer should be 1.9 times 10 power negative 4 ms negative 1. Okay, any question, dear? I like to using ratio like this so that some of the variable we just cancel out. Okay, we'll make it more easier. Okay, dear, here. Okay, resistor jack is replaced by a new resistor of smaller resistance. Okay, come back to here. Resistor jack. Oh, okay, this part. We are going to change into a smaller resistance. So this one resistance decrease. State and explain the effect, if any, on the terminal potential. Okay, here, as long as we close the switch, this one, terminal potential difference of the battery actually is asking you voltmeter reading. That means that our capital letter V. Okay, what happened to this V? When the resistor jack is replaced by a new resistor of smaller resistance. Think about this. I redraw the circuit. Okay, so this resistance decrease. What happened to your voltmeter reading? Voltmeter is somewhere here because this is for the battery. Let me draw it out. Battery. Okay, dear, let me check your answer. Prasan, let me check. Hmm. Prasan, the sequence not really correct. The sequence that you explain is not correct, but every single statement is correct. Not because of current like this, that's why your resistance like this. No, it's because resistance like this, so cause the current become what? So your sequence problem. Washini, Washini 3 marks. Is it 3 marks? Let me check. How many marks? Oh, 2 marks only. Okay. Oh, okay, okay. Washini, okay. Chonghan, very good. Your whole concept is exactly correct. Very good. Your concept is correct. Kai Qian correct also. But okay. Chonghan answer is difference of the battery will decrease. Okay. So our answer for this part, it will be decrease. Okay, why decrease? Because Chonghan say we replace the Z with a smaller resistance. So this one resistance becomes smaller. Then the total external resistance will decrease the total external resistance. Yes, your total resistance for this part, okay, it will become lower resistance. Okay, then after that, cause the total current to increase. Yes, your total current for the whole circuit will increase. And then the most important that Chonghan show that current increase will cause a greater loss of voltage. Hey, this one is very important. What is this, dear? This one got internal resistance. So V plus IR. You see, if your current increase, okay, this one is loss of what? Okay, loss of voltage due to the internal resistance. So this part, it will have greater loss. If you greater loss due to the internal resistance, this part, so your voltmeter reading at here, it will decrease. Okay, but then this one is only 2 mark. Actually, their requirement for this answer is very simple. As long as you mention that total resistance decrease, then you score 1 mark. Second mark is because they're asking you terminal potential difference of the battery one. So at here, you have to answering about this potential difference page 15, question D. Vashini, correct. Correct. Okay. If I add one more battery with the EMF 1.2, negligible internal resistance, so step whether the additions of battery Q will cause the current. Now we're talking about current to increase, decrease, or remain the same. Okay, so at here, resistor X. Okay, so at here, resistor X. Will it having any change for resistor X? My answer is no change. It will remain the V lah. Okay, so your IX at here, any changes? No changes. Okay, for your IX at here, dear, I repeat one more time. We think about this voltage. We think about this voltage. This voltage, it will still receive 1.2 volt. Even Okay, can you try with question number E? Can you try with question number E? Vashini, correct. This one should be easy, dear. Connected in parallel way. Okay, so parallel way is resistance is 1 over 6 plus 1 over 1.8. Inverse it. So at here, this one, your answer should be 1.2 ohm. Let me check your answer. Chonghan, correct. Sean, correct. Fatima, correct. Kai Chen, correct. Okay, dear, can you calculate what is the current in resistor Y? What is the current in resistor Y? Chonghan, correct. As I told you, why they got you to be here? Maybe this one will be used. So at here, if I redraw the circuit like this, like this. So this one is become 1.2 ohm. Then here, this is 0.60 ohm. Okay, then after that at here, the question asking you what is the current? What is this current, right? IY. So in this is already become the total current. Okay, Fatima, no. Sean, no. Vashini, yes. Manjo, yes. Dear, you see, why they asking you to find the total resistance in parallel? So maybe they want helping us to like for next step lah, okay, helping us. So at here I redraw the circuit. I know that this one combined become 1.2 ohm and this 0.60 ohm, this is for your resistor Y. They're asking you what is the current in resistor Y. So if we do in this way, this is a series circuit right now. Okay, series circuit, the current will be the total current. Alright, this one solve this. 1.2 total voltage equals to total current, total resistance. 1.2 volt is your total EMF equals to your current. This one unknown. Total current unknown. Total current that you get should be 0.67 ampere. Okay, so I know that I total actually is the current flowing through Y. Sean, did you round off? Should be 0.67. Okay, let me think. What else? Okay, dear teacher, why we cannot just using Vy equals to Iy Ry? I know this 0.6, but do you know about your voltage across Y? The problem is to calculate Y, Iy. Okay, so since I cannot solve by using this single part, then we have to change it to make a whole circuit. Okay, consider the whole circuit. Okay, any question for this? Okay, this one Vashini correct. Right there, 1.5. What is the current in the resistance wire? So what is the current at here? Current of the wire. So you just using 2.7 minus 1.5. Kirchhoff first law. So 1.2 ampere. That's all. Okay, let me check. Chonghan, okay. Sean, yes. Fatima, yes. Manjo, what is your resistance? Got any idea? Chonghan, yes. Chonghan, correct. Chonghan, correct. How about others? Any of you try and get the R? Parallel path. I can ignore the resistance wire first, because they are independent. Sean, two significant figure, thank you. Fatima, no. Jore, yes. Vashini, yes. Okay, dear, you look at mine, yellow color. This is a parallel line, parallel circuit, okay, parallel circuit. So I don't care about the resistance wire first, okay? The voltage at the bottom part will be still 12 volt, okay, parallel. Then my current in the circuit times the resistance 5 plus the unknown R. My current is 1.5 provided in the diagram, 5 plus R. So if you do it and do calculate correctly, so your resistance should be 3.0 ohm. Two significant figure there, okay? So this is the answer. Okay, let me look. Fatima, correct. True, 3.0, dear. Okay. Can we proceed to the next? Here, meter length. Z on the distance 1.6 is connected to the variable resistor. So there is a fixed resistor connected with the variable resistor. Determine the potential difference between point W and Z. W and Z. Oh, they want you to know about this. Can you try and then tell me your answer? John, John, you only calculate part of it. So 3 mark, you score 1 mark only. Chonghan, no. Chonghan, no. Manjo, wow, Manjo, yeah. Yes, Manjo, correct. 3 marks. Your final answer correct. So I assume the working step is correct. 3 marks. Good job, yay. So dear, for the rest of you, you have to find out. We put the voltmeter at there. You have to find the voltage difference. Washini, correct, yeah. Okay, dear, from here, you have to find out what is the voltage across XZ. Chonghan, yes. Then what is the voltage across XW? Okay, so at here, Vxz, you will get the answer is 9.6 volt. So here is 9.6 volt. So that means this part, if you minus, you should get 2.4 volt. Okay, the voltage across in another hands here, Vzy should be 2.4 volt. Okay, then I should know the voltage across the XW, bottom part at here. Okay, I don't get it. Why use current 1.5 to get the voltage of Z? Z, where is Z? 1.5? Chonghan, where is it? To get voltage Z, you use 1.5? No, I didn't using current to get the voltage at Z point. I using the ratio. Total is 2.0 meter. 2.0 meter, it will get the 12 watt. Then 1.6, how many watt I can get? 9.6. Okay, then for XW here, I will using I times R. Fatima, correct. Final answer correct. So there, this one, 1.5 times 5. So at here, we should get 7.5 watt, right? So in another hand, at here, VWY, which means that this part you get 7.5 watt. 12 watt minus 7.5 watt. Here, you will should be able to get 4.5 watt. Is it? Yes, correct. Yes, correct. So this one is 4.5 watt. Okay. Then I can using 4.5 watt minus 2.4 watt. So my answer is 2.1 watt. Okay. Sean, no. Sean, check which part you made mistake. Okay. The more correct idea, answer is 2.1 volt, dear Sean. Okay, the idea is like this. 12 volt, when it passing through at here, it will drop 9.6 volt. Here, it will drop 9.6 volt drop. Then comes to this point to here is 2.4 volt. Okay, then this 12 volt comes to this resistor, it will drop 7.5 volt. Then it will left over 4.5 volt for this part. So if you're using 4.5 minus 2.4, you get 2.1 volt. Then if you say that, teacher, can I using this 9.6 minus 7.5, you will still getting 2.1 volt. So final answer, what is the difference between these 2 points? It is 2.1 volt. 2.1 volt. Is that clear? Okay, the resistance of the variable resistor increases. Increase, yes, okay, this part increase. By considering the current in every part, so you have to talk about this part, and also total. Okay, set and explain whether the total power by the battery should be increased, decreased, or stay the same. Okay, think. When your variable resistance increase, at the end, what happened to the power by the battery? So at here, you should think about the total because battery is total. Then you have to talk about every single path. Try to give me the answer. What's going on with the power? What will be happen or effect on the power? 3 mark. So you have to explain 3 point. Chonghan, correct. Then you're trying to explain to get 3 point. Sean is Sean no. Sean no. Voltage for the battery is unchanged. Voltage for the battery at here all the time. Voltage across the battery actually is EMF. EMF won't be changed. So you are thinking in the wrong way. Resistance, always you think about what happened to the, you see, considering the current in every part. So you have to think in terms of the current. What happened to the current for every single part? How about others? Manjo, correct. Then why? What happened to the current? And then why you choose power like this? Why power effect is like this? So try to think and then tell me your answer. Vashini, yes, 2 marks. 2 marks. One more path you haven't mentioned. They say every part, current in every part. So Chonghan, Chonghan also 2 marks because same reason by considering the current in every part of the circuit. So you didn't talk about the current in the resistant wire, what's going on? Okay, Manjo. Hmm. Manjo, now we are increasing the variable resistor. No, you saying decreases. Then who else? Chonghan. Correct. Manjo typo. Okay. Fatima say resistance decrease. Okay, resistance decrease. Now they say resistance increase there. In wrong way. Fatima in wrong way. Okay, Wesley. Power decrease as the total resistance increase. So total current will decrease. Power equals to VI. V is constant, but I becomes smaller. So power decrease. Yes, 2 marks. I repeat, considering the current in every part. You guys lost 1 mark because you didn't mention about the wire part. Okay. So Kai Qian, resistance increase, so current decrease, power decrease. Then you only score 1 mark. Why? Every single part. So what happened to your current in the wire and in the battery here? Okay. Manjo, how to talk about the wire to get 1 mark? Current flowing through the wire, increase, decrease, or unchanged, dear? Manjo. Okay, Fatima, as the resistance increase, current decrease, causing the overall resistance to decrease, resulting to power to increase. Overall current will increase. 2 marks. Okay, dear, at here, every single part. Okay, we talk about the current in the resistor first. Current in fixed resistor and variable resistor decrease. Okay, because resistance increase, then current will decrease. Okay, then current in resistance wire is unchanged. Why? They are parallel, dear. They are parallel. Then this wire still receive 12 volt from the battery. It doesn't affected by the variable resistor at the bottom part. They are independent. So current in the fixed resistor, current in the resistance wire, and total current in battery decreases. Okay, so power equals to VI. Don't forget this one is talking about battery. So this one is actually the EMF. So at here, the same EMF. EMF doesn't change, same EMF. So power decrease. Okay, here dear, current decrease, so your power should be decreased. Battery. So the voltage at here, voltage for battery is talking about EMF. So EMF doesn't change, power will decrease because your current decrease. Then here you will lose mark is because they already told you considering the current in every part of the circuit. So they allocate 3 marks for every single path. Is that clear? Manjo, okay already? Everybody already finished writing down, huh? So we goes to the last question for this lesson 47. So can you please show that resistance of wire AB is 2.5? They give you the length, they give you the diameter, they give you resistivity. Okay, resistivity formula. Resistance is rho L over A. You have to memorize all the formula, huh? You are very good. Then at the end, you forget the formula, cannot. Oh, sorry, Wesley. Okay, the rest of you try, try to show the resistance of the wire AB. Wesley, if you finish, let me know. Finish, yes. Okay, dear. So at here, the resistance asks you to prove resistance. So this one, resistivity 5.1 times 10 power of negative 7. The length, remember, convert to meter, because here meter. So this one, cm change to mm change to meter. So it will be 0.5 divided by the area. Area is pi d square over 4. You have to know. So I move the 4 goes up and then pi d is 0.36 times 10 power of negative 3 square. This one is actually make sure you don't careless, then should be fine. So you will get the answer 2.5 ohm. This one should be fine. So here, can we go to the B? Okay, can you hear EMF is 6.0 is 100 so okay, if same metal, what physical quantity should be the same? They relate with the previous A question. So at here, write down same metal is same resistivity. Or maybe they say that, oh, just now I using copper wire. Now I using another copper wire. You found out that they are same material, same metal wire. Then they will be same resistivity. Okay, then at here, what is the current supplied by E? How you are going to solve this question? I give you some hints. You can calculate. Let me have a look. Current supplied by E, that means that total current. They want to know total current. If you want to know total current, that means that total voltage times equals to total current times total resistance. Now your task is you have to find the total resistance. Okay, you have to find your total resistance. So you got two tasks. You have to find what is this resistance, what is this resistance. Wire AB. Oh, wire AB just now we did calculation. So this one is 2.5 ohm. We label. In A, why it asking us to show? They give some information at here, 2.5. Now your task is you have to calculate the resistance for the CD. Resistance for CD is rho L over A. So can you able to calculate it? And then at the end, find what is your current. Same material highlight, same material, same resistivity. We can using the resistivity that they provide. So this one is Resistivity 5.1 times 10 power negative 7 times the length. 100 cm is 1 meter divided by pi. D is 0.18 times 10 power of negative 3 power of 2. So resistance for CD should be 20 ohm. This one is 20 ohm. So from here, can you do calculation to get your current? Chonghan, yes, correct. Manjo, yes, Manjo, correct, good job. Electricity not bad, Manjo. Washini, yes, correct. Correct. Okay, total resistance. These two is connected in parallel way. We can think something like this. Manjo. Your basic is good. Okay. 5 ohm, 2.5 ohm. So this one is 20 ohm. Total over 2.5 plus 2.5, which is 5 lah, plus 1 over 20, inverse it. So your total resistance for this circuit, it should be 4 ohm. So your total current, this is what we are going to count. Total resistance, after we settle with this parallel circuit, we get 4. Total voltage which is provided at here, this one is 6.0 volt. So this one is 6.0. Your current in the provided by the battery should be 1.5 ampere. Is that clear? Okay, my dear. Can you calculate the power transformed in wire AB? In wire AB, what is the power? Can you try? What is the power in the wire AB? I got the resistance already. So power formula, which one is better for you to use? Power AB. So if I using I square R, do you able to do calculation? What is your I? Washini, yes. Chonghan, no. Washini, which formula you use? Is it I square R? Yes, okay. There you see, let me give you guys some hints. You see this one is 2.5 volt. Here also 2.5 volt. That means that each of them will receive 3 volt, right? So at here, V, this one I move downward a bit. Okay. V for AB equals to I for AB. The resistance for AB is 2.5. So your I current AB should be 1.2 ampere. Then I can substitute at here, IAB is 1.2 squared times 2.5. So my answer should be 3.6 watt. This is answer for the next page, page 19. Okay, you can also using P equals to VI, P equals to VI or P equals to V square over R. Manjo correct. Chonhan, yes, correct. Chonghan correct. So there, if we're using V square is 3 square divided by 2.5, you will also get 3.6. You see, P equals to V square over R. Can I using this? Yes. You see, VAB is 3 volt. 3 square divided by 2.5. I still getting 3.6 watt. Again, teacher, how I know this is 3 volt? Dear, because this is 2.5 ohm, here is 2.5 ohm. So they will share this 6 volt equally. So it will get 3 volt. You need to have this kind of sense, okay? It's half, so it will share the voltage. Okay, dear, last question. Potential difference between the midpoint, this one midpoint, wire AB and the midpoint of CD. They want this voltage difference. Can you count? Manjo, yes. Manjo, yes. Good job. Washini, yes. Washini, yes. I move the B, this part to the next page, the answer to the next page. Okay, cut it. Goes to here. Okay, here. Or I can cut this one also. Cut it. Goes to here. Okay, come back here. My dear, let me check. New chapter today? No, we will discuss the MCQ, dear. I didn't send out the new chapter worksheet, dear. Chonghan 1.5 volt. Yes, dear, correct. Okay, dear. This one, if half of it, and here half of it. Here half of it, 3 volt become half of it, VAM, it become what? 1.5 volt. Am I right? Okay. Then VCN. What is the voltage across VCN? Dear, you see this whole length only got this wire. That means that the 6 volt is for this wire C to D. Okay, so the 6 volt is here, total 6 volt. Half of the 6 volt is 3 volt. So at here is 3.0 volt. What is the voltage across the M and N? You minus it, then you get 1.5 volt. So this is the last answer for the last part. I repeat, 6 volt share equally out. So this part is 3 volt. Then you divide half again. So it will get 1.5 volt at here. Then for the bottom part, the 20 ohm is the only resistance in this path. So total 6 volt will be given to it. Half of it, so it's 3.0 volt. Voltage between these 2 points, it will be 3.0 volt minus 1.5. So you get the 1.5 volt. Any question, dear? Any question? No question, then get ready with the MCQ question, dear. Okay. So here, let us come to this question. I will only choose a letter question, then we try to answer together. Can you go to this question number 3? This is 2022 question. Okay, the voltmeter reading is 0. So what is the resistance R? What is this resistor R? This one, resistor R. Can you try? Can we go back for a show? Yes, dear. Is it here? Okay. The rest of you try with question number 3. Done, Wesley? Why is wire can 3.0 volt? You means which wire? This wire? AB or CD? Wesley, you means AB or you talk about here CD? Why is the wire can 3.0 volt? This one is 2.5 ohm. Okay, this is 2.5 ohm. Just now we did calculation, so we get this. CN. Okay, CN here. Because dear, you look at this path, the only resistance is this wire CD. That means that this CD will receive 6.0 volt. Okay, 6.0 volt. Then here, it divided into half. So 6.0 volt will become here 3.0 volt and here 3.0 volt. Get it, Wesley? Then here 1.5 volt. In between here, become 1.5. Okay. Chonghan wrong. Question number 3, no. Manjo, where is the question? Oh, I found it. Hey, dear. You use iPad or what, dear? Manjo? If you... Manjo, correct. iPad, good job. iPad easy. You download, then you can write. If you print it out, then you have to print earlier, okay? So dear, this one okay, ah? So we go back to here. Manjo already get the answer. The rest of you? Washini, correct. Okay, dear, for those you feel complicated, actually, we can redraw the circuit like this. Like this. Like this. Then here is like this. And like this. Something like this. Okay? Dear, they say that this point to this point, what meter reading is 0. What does it mean? Meaning that your voltage across 2.0 ohm and your voltage across 5.0 ohm, these two voltage are the same voltage. Voltage for 2 ohm equals to voltage for 5 ohm. Am I right? Okay, here, how we find the voltage for 2 ohm? We can using the potential divider. Okay, potential divider. So we look at this part. This part we assume this is total Rx first. Rx easier, series in series. So at here, the 2 ohm divided by 2 plus Rx. Okay, it should be times with your voltage. Okay, times with your total voltage. Equals to, now we compare to the bottom part at here. It should be 5 divided by, this one is 10 ohm. 5 plus 10 times the voltage, total voltage. So boys and girls, you look at me. Now I'm comparing this path. Okay, this path. And I'm comparing this path. Okay? So at here, what EMF can cancel out. At the end, you do your mathematics, you should be able to get the answer is 4 ohm. This one Rx is 4 ohm. So here is 8 ohm. What is your R? Okay, so 1 over 4 total is equals to 1 over R plus 1 over 8. So at here, continue, you will get your question. Okay, this kind of question come out, in this 5 years, they come out 2 times. Similar question. So you need to understand voltmeter reading meanings what? Potential difference is 0. So the answer is D. Yes, correct, dear. Answer is D. Okay, is it okay? Then can we go to question number 4? We try question number 4. Try with question number 4 at here. If just now the one haven't finished writing down, then you have to let me know. Okay, we got 3 identical filament lamp PQR are connected to a battery of negligible internal resistance. Filament wire in the Q is black, so no longer conduct. Brightness in the brightness, what happened to change in the brightness of lamp P and R? Okay, I teach you all the time. Maybe we need to think. We feel like difficult to imagine or understand. It's okay. We can put some value for it. Okay, so for example, I teach you my technique. I can simply put a value 6 volt. Okay, then at here, I can say that this one is, let's say 4 ohm and 4 ohm. It will become 2 ohm. Okay, then this one also 4 ohm. Because they say identical filament lamp. So these 3 lamp must be the same. So I just put 4 ohm, 4 ohm, it become 2 ohm. 2 ohm plus this 4 ohm is 6 ohm. So I put this one as 6 volt. It's easier for me to do calculation. This one as 1 ampere. Okay, this is what I did. So at here, I know 0.5 ampere. Here is 0.5 ampere. Okay. Then, if we continue here, then since there is no Q anymore, so we will left P at here and then R at here. Okay, don't forget that the battery here still remain the same, which is 4 ohm. Okay, without the Q anymore. This, okay, 4 ohm and 4 ohm is the 8 volt, 8 ohm, sorry, 8 ohm. So this one will become I equals to the R is 8 ohm, 6 volt, current becomes 0.75 ampere. So this current becomes 0.75 ampere. Okay, what happened to the brightness? So right now we compare current for the lamp P. At start is 0.5 ampere. Now it becomes 0.75 ampere. So what's going on? Become brighter. Okay, it will become brighter. Let me check Wesley answer. No. Wesley, it should become brighter. Fawal, yes, Fawal. Okay, then how about the current in the lamp R? Initially, this one, 1 ampere, okay? 1 ampere, it becomes 0.75 ampere. So it should become dimmer. So your answer should be B. Sometimes, if let's say we cannot imagine, it's okay, dear. You try to put some simple value in and you see the effect. That is the technique. Washini B correct. Manjo B correct. Hey, good job, dear. Okay, is that clear? Okay, so there we goes to the, let me check. Goes to the question number 10. We goes to question number 10. The rest of the question, you can do it. And then question 7, we did it in our worksheet. So you don't refer to the worksheet, you're trying to answer, see whether you get the same answer or not. Okay, question number 10 at here. Can you try? Wesley, can go back to previous question. Yes, dear. This one? Okay. The rest of you goes to question number 10. I just simply put some value and make sure the value is easy to calculate. Then we see the effect. Question 3. Question 3 is here. Okay. Goes to question number 10. Some of the question we did it before. So when you try, after that you can check the answer. I think behind I got provide the answer. Question number 10. Actually, it's easy. Question number 10 is easy. Wesley, this question have you done? Okay, Fatima, no. Manjo, yes. Vashini, yes. Manjo, be confident, dear. Question number 10. Okay, question said that total EMF is 20 millivolt. Then thermistor X and Y, same temperature, same resistance, starting is same, okay? Then it wattmeter reading was showing 10. Of course, resistance is the same. Resistance is the same. Wait, why it doesn't allow me to write like? Okay. Resistance is the same. So if your resistance is the same, it will share equally 10 millivolt, right? Okay, then they say that the resistance for the X here become double, is 2R. Then Y is resistance become half, R over 2. So asking you what is your new voltage? Okay, what is your new voltage? Let me have a look. Wesley, no. Wesley, no. Let me check. Who else? Chonghan, yes. So dear at here, your voltage across Y should be your R over 2 divided by R over 2 plus 2R. So times with your total 20 milli. Okay, so you use your mathematics, blah, 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 blah. So you should get 4 milliwatt. Answer should be A. The rest in between, I'm not going to show is this is mathematics. You have to move there and then out and out cancel. So at the end is 4 milliwatt. Okay. Then next, I want to go to the question number 13. Try with question number 13. This one settle, I move, question number 13 here. Volume unchanged. Fatima, no, try again. Washini, correct. Good job. The rest of you also try, dear. Resistance for the stretch wire. Okay, for those who have no idea, then you refer to my working step. Answer should be donkey. A bit long working step. Wesley, no. Wesley, check your working step. Manjo, no. Fawal, D, correct. Fawal, good. Okay, the rest of you, can you check and then you tell me, oh, is it you are stopping at here, then you choose the answer 1.13? Is it? Like, is it you stop at this page, this step? The whole working step should be this. Okay, we find out the relationship between the L1 and L2. Okay, because we know that the volume still the same, area change, then the length, what is their relationship? Okay, then we do substitution. Resistance of the stretch wire, that means that it's still the same material wire. We continue using the wire to stretch it, right? So same material, same resistivity. That's why at here I can cancel out the row. Resistivity cancel out. The rest of it is just do some substitution. Cancel, cancel, cancel. We get the resistance, new resistance. When the diameter change, when the length change. Manjo, can you tell me, is it you stop at here, that's why you choose B? I want to know. Why you and Wesley, is it Wesley just now? B, two of you choose B. Reason is, you stop at the length, is it? Forget it was a diameter, okay. Okay. There until here, okay? The rest of you, we can go to, let me check. Can you go to question number 30? 30, test your concept, 30. Question number 30, test your concept. This question done, Can I move forward? I goes to question number 30, 30. Wesley, is it okay? Sean, okay. Manjo, okay. Wesley, Wesley? Okay, move. Question number 30. Okay, this one, test your concept. A student record the ammeter and voltmeter reading. She then connect a second identical external resistor in parallel with the first one. What happened to your ammeter reading and what happened to your voltmeter reading? This question is, I want to test your understanding. I think this question Chonghan can answer because just now the structure question, Chonghan concept is very good. So this question should be fine for you. I try. Manjo, no. Manjo, no. Wrong, 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 Manjo. Fawal, no. Wesley, 50%. Choose one. Manjo, yes. You cannot tikam, Manjo. Have to understand why. Wesley, no. You tikam wrong. Kai Chen, no. Washini, yes. Dear, look at me, This is internal resistance. As I told you, whatever internal resistance, we write the formula E equals to V plus I R. Am I right? When you connected one more resistor at here, ask yourself what happened to your internal resistance right now? What happened to your total resistance right now? Parallel, so your total resistance should be decrease. Chonghan, correct? Okay, total resistance decrease. So ask yourself next step, resistance affecting what? Current. Current will be increased. So answer either C or D. Okay, when current increase, just now Chonghan got explained. So here, it will have a greater loss of volt at here due to the internal resistance. So your IR here higher. So this one, first step, second step, third step, and last step at here, your voltage will be decreased. Answer is C. And actually, this question just now, structure, we did it. Should not be wrong again. Okay. Okay, dear all, what do you think if next lesson we continue selected few questions? Then we complete it within 1 hour. Then another 1 hour, we start with the last chapter. What do you think? Is it okay for you? Okay, the question before, I think question you can try whatever question Okay. Manjo okay You can try until question 38. Okay, give you some tasks, do your homework. Okay, do until question 38. Then next week we select some of the question for the first hours we discuss. Then after that we go to the new chapter. Okay, so if no question for today lesson, that's all for our lesson today.